Okay, so good morning everybody, good morning again. I'm Alvise Bragadin, University of Bologna, Associate Professor of Construction Management, and we are here with our team. Especially now I will represent you what we did for the ET4 Digital Project. Our task was the work package number 3, so the construction digital twin implementation. Okay, so just a short introduction about digitalization of the construction sector. So think that the digitalization of the construction sector has the task of the objective of overcoming typical challenges of our construction sector, integrating tasks of different operators of the value chain, improving project control, improving change management, improving design and planning. So construction operators, particularly small and medium enterprises, are facing barriers to digitalization. We will see some of them. So surely training, cost implementation, data interoperability, standardization of digital formats, files. So the ET4 project aims to increase the quality and effectiveness of the training of trainers and teachers in the construction sector in the field of digital technology to overcome these barriers. So the goal is to decrease digital barrier for small and medium enterprises by the implementation of education and training activities and use of open access tools. So in our objectives, so surely there is the professional training courses, designing the professional training courses for teachers to support the digital transition, but also the development of a demonstrator, so a digital twin for construction project management that has the task of allowing real-time project control. So this was mainly our task, and we did it with the ET4 platform that was it was part of our task. So few words about digital twin. So what is digital twin? Everybody knows what is digital twin because we are always talking about virtual environment, digital twin. So it's a digital representation of a target entity. For us, it's a construction project. So what we can see just on the other side of the window. So with data connection that can enable the convergence between the physical and digital state. So there is a synchronization between the digital twin and the physical twin, so the construction project. So the relationship between the two is much, maybe it's the very important thing is much more important maybe of the two different things considered as single entities. So it is a digital twin. It's a model of a real world expected future or actual product, or a model of a system, a process that has the task of simulating the behavior of the physical twin in the different stages, in production, in testing, during operation, maintenance. So the digital twin is replicates the physical system to predict failures and opportunities for changes, to prescribe management activities, operational action on site, optimizing and try to mitigate unforeseen events to reach the project objectives, so the final task of the project. So what is very, very important is the relationship between the digital twin and the physical twin. So how we are transferring information from the construction site to the digital construction side. So sensors, but also manual surveying activities. So this is very, very important, because what is important is having a relationship between the digital and physical entities. So some words about the history of digital twin. The first digital twin, maybe not labeled as such, originated in the NASA in the 1960s as a means of modeling Apollo missions. So NASA used a simulator to assess the failure of Apollo 13 season tanks. And then okay, it's a long path. The idea of digital twin is by David Gellenthal in the book Mirror Worlds, and the name virtual twin is by Hernandez 1997. But the digital twin concept is the very well-known digital twin concept is by Michael Reeves. He is a professor at the University of Michigan. He's an industrial engineer. He was head of the Product Lifecycle Management Center, and he was the one that, in a way, set the digital twin concept. So there is this main concept that is the idea. The main idea is that the digital twin is made of three parts. So there is a physical element in real space, the virtual element in virtual space, and that information that provide the connection between the physical and the virtual element. So the digital twin is not a copy of the physical product, but it's the interaction of data between the digital world and the real world. So there are many categorizations. So there is a digital twin environment where, in a way, digital twins are. So also Greece said that there is a digital twin prototype, that is something that needs to be developed. So is the digital twin prototype holds in the system all the data information needed for creating the product. There is a digital twin instance that is the digital twin of every single component that is connected, component of the product that is connected to the virtual system. And so the digital twin aggregate is the aggregation, the complete set of all the digital twin instances, the set of all the digital twin instances. And there is also another classification. There is digital model, digital shadow, or digital twin, depending on the data flow, or data flow between the physical object to the digital object. So actually what we will have here is surely something very similar to a digital shadow. So we have automatic data from the physical object to the digital object, and manual data from digital object to the physical object. Okay, something about the problems, the background in the digitalization of small medium enterprises. So what is digital twin construction? Digital twin construction is technology that is used to synchronize physical assets with their virtual counterparts to provide real-time monitoring, predictive insights, and performance optimization. So the integration of digital twin construction offers several benefits, including enhanced project visualization, real-time progress tracking, the ability to simulate and optimize construction process. So what is very, very important is having a build information model. That is in a way the base of the database that we are using for the work we are creating with the digital twin. And what are the problems of small medium enterprises in the construction sector? So surely small medium enterprises of construction sector, they are searching for low cost solution. So most important barriers are budget constraint and the complexity. So they need training, because all the system, the platform that we see, need to be operators need to be trained for using the platform. Also, which are the tasks that they are searching for? The tasks maybe are tasks related to project control. So construction scheduling, process monitoring, change management, reporting of issue, quality assessment. So education is a cornerstone of innovation. So what we are aiming? We are aiming to create a cyber physical production system. So construction sector is very far from this, as far as I know, because the cyber physical production system means that every single stage of the product is in a way tracked, controlled, and assessed by the digital twin, by automation, digital automated systems. So this is maybe what we will aim in our sector. For our work was very important the categorization of the 3 generation of digital twin made by Boji, and so he proposed a progressive evolution approach to construction digital twin. So the first generation is what we had in the first stage is monitoring platform. It's an enhanced version of being on construction site today. The second generation intelligent semantic platform consists of an integration between BIM models that are in the digital platform and IoT devices, sensors, so creating a knowledge base of data. And the third generation is agent-driven social technical platform. So it will be a fully semantic digital twin with the use of artificial intelligence and all the things that artificial intelligence can bring. Okay, so the perspective for research work for construction digital twin are surely the conceptual design and framework that are needed to be created in the construction sector, and also the development of semi-automated pipelines of information. Okay, also think that we are aiming at the construction site, aiming at construction projects, so the construction digital twin concept should reflect the actual construction management process to be performed for project control. So it should be based on the Deming cycle, so the plan, do, check, act. So the digital twin should give support to the project management process by supporting this PDCA process. That it's the engine of all the quality system and of, in a way, some project management system. So now where we are, this is our work package, work package number 3 of the ET4 Digital Project. So the very first part of the work package, we were building, constructing, setting the innovative demonstrator for digital ecosystem as being a pilot project. We created the construction digital twin and the platform that creates the digital twin environment. Now we are in the transnational training for trainers. So we are in the understanding and using the demonstrator, so improving the training of trainers and teachers to support that construction company in the use of digital twin. And then the next step will be the development of guidelines for the replicability of the demonstrators. So this is our phase. So what we did with the pilot construction project created by the vocational school, the IIPLE students, we created a construction digital twin of first and second generation, addressing to the second generation, using the open project BIM platform. So this was our strategy. So in the very first phase, March and April, we developed the digital twin based on the construction site. Then we were setting the demonstrator and installing the sensors, and then we have the completed demonstrators of second generation. And we are testing on operation of the pilot construction project. So this is your work. Okay. This is your work. Okay. So the pilot project has been built by students at the ET4 Vocational School for construction operators. And this is the physical twin. So the actual pilot construction project. And then there is the digital twin is the 3D BIM modeling on the Open BIM digital platform, and all the system of creating relationships, the survey system, the sensors, and also a repository of project control tools. Okay, so again, this is our physical team, the mock-up construction project. And so the digital twin is the platform. The platform, we use an existing platform, the Open Project BIM digital platform, to create the construction digital twin environment. So this Open Project BIM has an IFC viewer. So after uploading the 3D BIM, all the players, the stakeholders, can view the model without having Revit, without having a specific software, but just accessing to the platform that is a web page. So it's a very, very simple tool. It's a very simple tool. And so it's a tool that can also, well, it can change. So I think that I'm working as in construction management. I've been working in construction management for almost 30 years. So I think that this can actually change the construction sector, because the digitalization can change the way we are working on site, because accessing data, accessing the SP project, well, this can really change something. Okay, then just a quick overview about what we did. It will be also explained better later in another presentation. So this is the BIM model. This is the LiDAR 3D scan that was done with an iPhone with the free app, and then uploaded the different stages of the project. Okay, and also we uploaded in the platform project control tools, so the bill of quantities, the pricing bill of quantities, the project schedule with Microsoft Project, and also we can update the bill of quantity and the project schedule. This will be our task tomorrow. So tomorrow we will play with this and having some role playing. So this is our task tomorrow, understanding how to deal with the existing physical construction project and updating or getting information from the platform, and also updating the platform, or also answering from creating meeting, answering from issues, quality issues that you can detect on the actual construction site. So the Open Project BIM environment is okay. It's quite simple, but what we understood that a training is needed. So You know, it's a web page that has many information, the project description, the pictures, photographs are very important, very important. So, then the LiDAR survey. It was a little bit difficult to have the LiDAR survey on the S-built model, and also assessing the project status. And so there is a specific Gantt chart. So there is the WBS. So we can update the WBS with the project the physical percentage of completion of work packages. So we can create the stage payments, and also we have sensors that are giving us data about air quality, dust, temperature, that is camera, and the number of workers. So we tried to digitalize all the project control processes that with the plan to check act system. So there are something that is done on the physical twin, but digital twin functions and resources can help to the project control process. We also created project control KPIs, so to understand the progress, project progress on site. Okay, and then I can skip this because, okay, sensors. So sensors are needed to monitor environmental condition on site, and visually they are presenting the site progress. So we have environmental sensors that are detecting air temperature, air pressure, humidity, air quality, dust, particulate matter, gases, and the camera. So these sensors are being connected to the Open Project Bin, will be part of the following presentation. Okay, this is okay. Where sensors are hidden, so nobody can see them, but they are there. Okay, and this is a picture. No, not the Andrea will show the picture. Okay, by the camera that we have. Okay, and okay, so 5 phases. Okay, so what we did? We did the project acquisition, so detection of understanding the project. We created a digital model. We created the project control tools. We created a construction digital twin environment development environment with the Open Project Bin platform. We installed the sensors and connected to the platform, and then we performed on-site data gathering, so manual data from site survey, measurement, 3D LiDAR scans with the 3D point cloud, and also automatic data from sensors, so the number of workers, pictures, air quality data, and manually we updated the model. So and then the 5th phase is on-site data interpretation and process control activities. So we worked in a team of 5, including 1 IT technician for 4 months. Okay, so discussion. So what we need, I'm going to conclude. What we have real-time monitoring and verification. We have data collection for future analysis, life cycle documentation, education, and so forth. So, okay. So, okay, we have some limits. So ET4 Digital is an educational project. So it's a smaller Erasmus K-A2 action project. So we didn't invent anything, just implemented existing tools and method, but the research work was aimed at demonstrating that it is easy to create easy in a way, easy to create a construction digital twin. So everybody can do it. Everybody can do it because we just use something that we have in the market, that it's very it is accessible for small and medium enterprises. So our success is surely the centralization of information. And the time to access to data and information. Surely this is something very, very important. Real-time acquisition of project control data, pictures, the temperature, linking WBS items and the object, so avoiding mistakes in collecting data and understanding the physical percentage of completion of. Okay, many thanks.